Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department at SNS College of Technology, an autonomous institution, Coimbatore. So, in this YouTube video, we are going to discuss the 19 EC 0301 Consumer Electronics subject, the Unit 1 audio system, for the clear view topic of characteristics of microphone. In the previous video, we have discussed what is mean microphone and how the microphones are classified based on how they are working. So in general, a microphone is an electronic transducer which converts an normal sound waves into its corresponding electrical signal waves based on pressure and velocity based. So based on the output of microphone, it is classified as a pressure based microphone and velocity based microphone. So in this YouTube video, we are going to see the various characteristics of microphone. So how the microphones are working and what are the necessary characteristics of microphone we are going to see. So there are four important characteristics of microphone. The first one is the output level, the second one is the frequency response, the third one is the output impedance, and the fourth one is the directivity. These characteristics are ultimately determine the particular type of microphone suitable for a given application. For example, a microphone can be used for inside the classroom, or whether the microphone can be used for a large group of people meeting conducted at the open auditorium. So both these environment are changed, but the microphones are common. So how these characteristics are varied? The basic type of microphones are grouped according to the principle of operation, that are carbon, crystal based microphone, dynamic based microphone, ribbon type of microphone, and capacitor type of microphone. So now we see the characteristics one by one. First, the important characteristics are output level. The output level of a microphone governs the amount of amplification that must be available for use with the microphone. That is how much of sound that the microphone can produce. The output level of microphone is usually given in decibel preceded by a minus sign. The minus sign means that the output level is so many decibel below the reference level of 1 milliwatt for a specified sound pressure. The unit of sound pressure used for rating microphone is referred as a bar. A bar is equal to sound pressure of 1 dyne per square centimeter. Speech provides sound pressure between 0.4 and 15 bars. For music, the pressure ranges from 0.5 bars to 1250 bars. Next, and the second important characteristics are frequency response. The frequency response of a microphone is a rating of the fidelity of a relative output voltage which result from sound waves of different frequencies. That is how a microphone can be operated at various frequencies. For example, the same microphone can be operated for low frequency voice also, high frequency voice also, or the mid frequency voice also. Apart from these three frequencies, how a particular microphone can be suitably used for all the various different frequencies. The simplest way to find a complete picture of a frequency response characteristics of a microphone is to plot a curve of its output voltage versus its input frequency. Since a good modern microphones are relatively flat over the range, it is often considered sufficient to specify the range over which their output doesn't vary more than plus or minus 1 or 2 decibel. For an ordinary home, high fidelity use of microphone frequency response curve should be reasonably flat between 40 and 1000 Hz. For indoor use, we are using a microphone of operating frequency 40 to 10,000 Hz. With system designed specifically for speech reinforcement, a lower limit of 150 Hz and upper limit of 5000 Hz is entirely satisfactory. So next we can see how these frequency curves are drawn. So if you see this figure, the frequency curves are drawn by taking the frequency in x-axis and the output level of decibel in y-axis. So these graphs shows how individual microphones are operated in various frequencies. Next and important characteristics are output impedance. A microphone, like any other component with electrical inputs or outputs, have a value of impedance. When a microphone is connected to an amplifier, a complete circuit is formed and electric current flows whenever a sound causes the microphone to generate an electric voltage. For most high quality microphone, impedance is very low. A few ohms ranging up to 100 ohms or a little fraction of ohms is used in ribbon microphone. So in general, a capacitor and ceramic crystal microphones have high impedance. The importance of microphone impedance is not a matter of the precious value, but it is the ability of the microphone and the recorder to be matched together. Suppose if the impedance is not matched between a microphone and a recorder, there is a noises which is happened in signal amplitude and a frequency range. So in order to avoid this, a pure quality of sound, in general, a high impedance microphone is used for communication. So in general, a ceramic capacitor or a capacitor based microphone is connected to low impedance amplifier input, and the output from the amplifier is small and the lower frequency are reduced, this proportionately producing an unpleasant still sound on playback. So cassette recorders of good quality are not as a rule designed to take high impedance microphone, except when such microphones are supplied with a recorder, and if for any reason such microphones are used, a high impedance pre-amplifier must be used between the microphones and the recorder. So in order to avoid a low burst sound, we are using an amplifier in between a microphone and the recorder, where the amplifier either it has to increase or decrease the noise of the input signal. If a low impedance microphone is used, and this will produce a hum problem in a normal amplifier. Next and the last important characteristics are directivity. Microphones do not respond equally to sound reaching them from all directions. Their frequency response characteristics also vary depending on the angle at which a sound reaches them. So that is why in every open auditorium or any microphone are used that is placed near the speaker. A microphone may respond equally to all frequencies between 40 to 10,000 Hz when the sound is originating directly in front of it, while the high frequency response fall off rapidly as the sound originates further to either side. Where it is necessary to pick up sound from all directions, the directional characteristics of microphones are not suitable. The way in which a microphone responds to sound coming from different directions is plotted on a circular graph which is known as a polar diagram. The center of the circle is the 0 point, and concentric circles indicate a successively higher level of response as they move outward. The top of the circle is the front and the bottom of indicates the back of the microphone, and the straight line radiating from the center denote the corresponding angles. So next slide we see what is the polar diagram. So this is the two types of polar plots which are taken from omnidirectional and cardiac pickup pattern. When the directional response of a pressure gradient microphone is plotted, the shape of the figure is something like a heart shape, while the maximum response in the front and the curve around the side to a minimum near the rear. Therefore, it is termed as cardioid. So, whenever we are taking any microphone, the main important characteristics are the four one. First one is the output level, second one is the impedance characteristics, third one is the directivity, and the last one is the frequency response. So, depend upon the characteristics and the quality, these characteristics are varied based on the microphone which we are used. So, for a good receiving signal, a minimum of 1 feet to 2 feet is placed between the microphone and the center. So this figure shows the directional directivity pattern of a super cardiac pickup pattern and a figure of 8 pickup pattern. So thank you for watching my video. So in this video we have discussed the important characteristics of a microphone, that is how a microphone is varied based on impedance changing, directivity changing, frequency response changing, and the output level changing. So in the next video we are going to discuss the what is the meaning of headset and headphones, how they are commercially used in a real-time application. Once again, thanks for watching my video.